The speed of air flow on the upper and the lower surfaces of wings of an aeroplane are V1 and V2 respectively. If A is a cross-section area of wing and rho is density of air, then the upward lift is. So we know the from the concept of this aerofoil, we know that some amount of air molecule are moving through the upper surface and some amount of air molecule are moving through the lower surface. And the velocity in the upper surface will be more as compared to that of lower surface. Let's say, and according to the question, it is given that the speed of airflow on the upper and lower surfaces are V1 and V2 respectively. And we know that the value of V1 is greater than that of V2. Because of that, pressure at point 1 will be less than pressure at point 2. Now our aim is to find out the net uplift over here. So just consider that pressure at the bottom part is equal to nothing but P2, and pressure on the upper surface of wings of aeroplane is equal to nothing but P1. So we know that because of this difference in pressure, there is a force acting in upward direction. So let's say the pressure P2 is acting some force or exerting some force on this one in upward direction. Let's say that force is F2, and because of this P1 there is a force F1 is acting in downward direction. So we can write the value of net force acting on this one. So the value of net force will be equal to force acting in upward direction minus force acting in downward direction. We are taking upward direction is more because P2 is greater than that of P1. And force we can take as pressure into area. So let's say the cross-sectional area over here is A. You should not take the curved surface area for calculation. We need to observe an area which is perpendicular to that of force. So that is, we can take it as cross-sectional area A. That will be same for both the surfaces. So we can take it as it is P2 into A minus P1 into A. So we can write the value of net force will be equal to nothing but P2 minus P1 into A. Now we can find out the value of P2 minus P1 from the Bernoulli's theorem. Like we are going to apply Bernoulli's theorem between the point 1 and point 2. So point 1 pressure is P1, and we can take it as half into rho into V1 square plus rho into G into H1 should be equal to pressure at point 2 P2 plus half into rho into V2 square plus rho into G into H2. Over here, like if I'm taking this one as a reference line for the measurement of gravitational or difference in gravitational potential energies. So this there will be some difference, but the density of air is negligible, so we can cancel the difference between them. We'll assume that they are almost same and we are neglecting it. So we can write our equation becomes something like P1 plus half into rho into V1 square is equal to, we'll write P2 plus half into rho into V2 square. Now we can write the difference in pressure, that is P2 minus P1. So we can write this P2 minus P1 is equal to, here you can take the half into rho into V1 square minus V2 square. So this is the value of net force acting on it. From that, this is a difference in pressure, but our aim is to find out the value of net force. So we can write net force is equal to P2 minus P1 into A, which is equal to nothing but half into rho into V1 square minus V2 square into A.